consider this 3D problem. So what we're given is this diagram over here, and that we need to find the height of the pole. So here, for question number A, we basically need to look at this triangle, the X. Always try to draw out the relevant triangle. So this is B, P, and this is A. Over here is 25 degree, all right? And AB is going to be, well, obviously this is going to be, because ABC is a rectangular, so AB is the same as DC, so it's 3 meters. And we need to find what PB is. And tangent of 25 degree is going to be equal to PB over 3. Therefore, PB in this case is just going to be 3 of tangent 25. So only use the calculator at the last stage. So mine is in radians, so make sure that you change it into degree mode. Right, press enter. And now you're going to calculate 3 tangent 25 degree. Okay, 3 tangent 25 degree and find the answer. Well, this is roughly 1.40 to 3 SF. In the examination, always report exact answer or to 3 SF. All right, so question B, find the angle of elevation of P from D. So what we're talking about is this, angle of elevation of P from D. So this is the angle that I want, this one in red. So in order to get this, first thing to do is to find the length DB. So we start with the rectangular plot on the ground, that it is A, B, C, and D. I need to find DB. This is 2, this is 3. So using Pythagoras theorem, it is easy to calculate that this thing here, DB, in this case, this is B, this question A here. B in DB is the square root of 2 square plus 3 square. So that is 4 plus 9, or square root of 13. Here is a positive number. And then next thing that I need to have is this right angle triangle. This is D, P, and B. PB we obtained just now is 3 of tangent 25 degree. All right, whereas DB is square root of 13. Therefore, I can find out this angle here. So what we have is the opposite and the adjacent. So we can use tangent of PDB, in this case, is 3 of tangent 25 degree divided by square root of 13, or PDB is equal to the arctangent, this is inverse of tangent, of 3 tangent 25 degree over square root of 13. So now I will use my calculator. So in using your calculator, so please, so we have arctangent, and then we have bracket 3 tangent, and then 25 close bracket and close bracket divided by square root of, all right, 13, close and then close bracket, and this is my answer. So this is roughly 21.2 degree to 3 SF. First, sketch out a diagram. So the diagram that I'm going to sketch out is this. An eagle, so for this one, we're going to say north is this, okay? And here's my building, and this is O, and this is the top of the building, so that's a T. And due west is this side, okay? Due west is 20, so here's the red, that's the eagle here, so it's R here. The eagle is on top, so let's call the top here E. And then the angle of depression is measured from the horizontal, and we're going to call this 30 degree. 30 degree. If it's a horizontal ground, then these two lines are perpendicular. So there's two lines are parallel. Therefore, this is also going to be 30 degree. Here is 90 degree. That is, we assume that the building is actually vertical. Now, what do we have? And then you will, the eagle sees another red due south over here, which is at 18 degree due south. All right, and over here is 18 degree. That means over here is also going to be 18 degree. And we want to find, this is red number 2, and we want to find this distance here. All right, between R and R2. First, trying to figure out the first right angle triangle. The first right angle triangle of interest is this one. This is O. This is my R, and this is my E. And height here of the top of this building is 20 meters, and the angle of depression is 30 degree. Because these two lines are parallel, then this is also 30 degree. So the first thing that I'm going to do is to find out what RO is. So we have tangent 30 degree is equal to 20 over R0. Therefore, R0 is 20 over tangent 30 degree, as it is. So the next triangle that of interest is this. This due south, that is, this is O, this is R, and this is R2. And this, so I need to find this. That means I need to find, I have RO now, and then I need to find OR2. But in order to find OR2, I need to get it from another right angle triangle. That is this one, O, E, and R2. The angle of depression in this case is 18 degree. So this one is also 18 degree. Here is 90 degree right angle triangle. The height here is 20 meters. So similarly, we have tangent 18 degree is equal to 20 over R20. So R20 itself is 20 over tangent of 18 degree. Now, Pythagoras theorem, that is this is equal to the square root of RO, everything square, plus R square O, everything square. So we have square root of RO in this case is bracket 20 of tangent 30 degree, everything square. All right, I extend the page a little bit, and then this is 20 plus, next is 20 over tangent of 18 degree, everything square. All right, so now we need to calculate what this is. All right, and then bracket, I have 20 divided by tangent of 30 degree, bracket and bracket, everything square, and then plus another bracket, 20 divided by tangent of 18 degree, bracket, everything square, and then close the bracket and press enter. So you get about 70.6 meters 3SF. That is, these two reds are about 70.6 meters apart.